Hello, this is Mr. Miller. Welcome to video 4b, the general power rule. We're going to study how to take the derivative of a function raised to a power. This is a special case of the chain rule and a very handy formula to use. So we're going to start with a couple of comparisons. This first function requires the simple power rule. We have y equals x to the 100. So if we take the derivative, we'd have y prime equals. Well, we multiply in front by the exponent, so it'd be 100. X raised to the 100 minus 1th power. That'd be 99. We subtract 1 from the exponent. So that's the power rule we've been doing for a while. Now, this is the general power rule here. A function raised to a power. It's very similar. So to find the derivative, y prime, we're going to multiply by the exponent. It's the same inside function raised to the same power minus 1, or 100 minus 1, which is 99. Okay, times the derivative of the inside function. Well, that would be 8x in this case. So if I multiply 100 times 8x, I get 800 x, that's an x, times 4x squared plus 9 to the 99th. Okay, so you multiply by the exponent. It's the same inside function to the 1 less power times the derivative of the inside. That's how we do the general power rule. So here we have another case. This time we have a coefficient 6 in front. So we learned earlier that we do 9 times 6, that's 54. And it's x to the 1 less power, which would be x to the 8th. Okay, it's the same thing when it's a function raised to a power. So in this case, we would multiply 9 times 6 and get 54 again. It's the same inside function raised to the 1 less power, so 8, times the derivative of the inside function, which is times 3. All right, then we simplify. 154 times 3 is 162. I'm sorry, 54 times 3 is 162. And it'd be 7 plus 3x raised to the 8th power. Okay, so this is the way the book presents the rule. If we have the derivative of a function u of x represents a function. So if we have y equals u of x to a power, this is the rule for taking the derivative. This is what we were just doing. You multiply in front by the exponent n. It's the same inside function raised to the nth minus 1 power times the derivative of the inner function. Okay, let's look at some examples. So here we go. It says find the derivatives. So we have a function raised to a power. So no problem. Here we go. Y prime equals 7 times the inside function raised to the 1 less power, so it'd be 6, times the derivative of the inside function, which would be 2x minus 3. Okay, now I'm just going to leave it. There's not much I can do to simplify that right now, so we'll just walk away. Here we go. This one, we have sine of x raised to the 4th. It's being multiplied by 6 in front. So y prime would be 4 times 6, which is 24. The inside function raised to the 1 less power times the derivative of the inside function. That would be cosine of x. And we're done. Okay, now sometimes we have to rewrite the function if we want to use the power rule. So I have to write this as something raised to a power. So I'm going to rewrite this as 6 times 3x minus 10 to the negative 4th. So this is in the form now that I can apply the rule. So y prime would be negative 4 times 6 is negative 24. 3x minus 10 to the 1 less power, well, negative 4 minus 1 would be negative 5, times the derivative of the inside, times 3. Okay, Negative 24 times 3 is negative 72. And I can put this guy in the denominator because it's to the negative 5th power. So this would be over 3x minus 10 to the positive 5. Okay, let's do square root of tangent x. So I'm going to rewrite it. So this is the same as tangent x to the 1/2 power. Now we can use the power rule. So the derivative y prime would equal 1/2 tangent of x to the minus 1/2 times the derivative of tangent, which is secant squared x. Now, secant squared will end up in the numerator. Tangent x to the 1/2, or the square root of tangent x, will end up in the denominator. We have a 2 that will end up in the denominator. So we have y prime equals secant squared. And in the denominator we have 2. Like I said, if I move this to the denominator, it would be tangent x to the 1/2 power. But I'm going to write that as square root of tangent x. There we have it. There's the derivative. Okay, let's try this one. Again, let's rewrite it. The square root's in the denominator, so that's the same as the negative 1/2 power. So we have x squared plus 4 to the negative 1/2. Okay, time for the power rule. So y prime would equal negative 1/2 x squared plus 4. If I subtract 1, we would get negative 3/2, because negative 1/2 minus 1 is negative 3/2, times the derivative of the inside, which would be 2x. Okay, all that's left is to simplify. Negative 1/2 times 2x is negative 1x, or just minus x. That goes in the numerator. And then in the denominator, we have x squared plus 4 to the 3/2. I'm just going to leave it like that instead of trying to switch it to a square root. We could if we really wanted to, but the 3/2 power, that's fine. Leave it like that. Okay, now we're almost finished. I have 2 challenge problems. They're challenging because, well, they involve a combination of rules. All right, so let's start taking the derivative of this, and we'll see where we kind of get in a little bit of trouble. Y prime equals, well, we're going to multiply out front by 6. It's the inside function raised to the 1 less power to the 5th. Here's the problem. I need to multiply this by the derivative of x minus 2 over x plus 5. Well, we know how to do it. It involves the quotient rule. So maybe up here I'll write the quotient rule just to remind us. It's g f prime minus f g prime over g squared. All right, so we have all of this times the derivative of the inside. So that'd be times, well, the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, we got this. So 6 times x minus 2 over x plus 5 to the 5th. All right, when we distribute, we have x plus 5 minus x plus 2 over x plus 5 squared. So there's 6, x minus 2 over x plus 5 to the 5th. And let's see what's left here. X and minus x cancel. 5 plus 2 is 7. And we have x plus 5 squared. Okay. Now, that would be fantastic to get that far. I can simplify a little bit. So this next step, we can do or not. 6 times 7 is 42. We have x minus 2 to the 5th. And we have x plus 5 to the 5th times x plus 5 squared is x plus 5 to the 7th. It's a little simpler. So I'd be very okay if you got that far. If you made it that far, oh, you're a genius. But there are different ways of simplifying it. And so maybe we can combine things a little bit. Like I did x plus 5 to the 5th times x plus 5 squared is x plus 5 to the 7th. Those are just algebraic details. All right. Last one, another challenge problem. So this one's very similar. When we get to the derivative of the inside function, we have some work to do. So here we go. Y prime equals 9 times sine of x over x plus 2 to the 1 less power. Here we go again. When we take the derivative of the inside function, it's a quotient. So we need the quotient rule again. So g f prime minus f g prime over g squared. So that would be x plus 2 times cosine x minus sine of x, and g prime would be 1, all divided by g squared, x plus 2 squared. And you know what? We're going to walk away from this like that, because there's not really a whole lot I can do to simplify the numerator. I'm kind of stuck with all that, but that's what it is. That's the derivative. Okay. I got 3 for you. These aren't so bad as those last 2. So in each case, take the derivative. In part B and C, rewrite them so that you can use the power rule. So rewrite them so it's, in this case, 2 times 4x plus 7 to the negative 5th. And this has sine of x to the 1/2. And you should be okay. The general power rule is right here if you need it. I'll see you in class.